to apply the Stokes theorem on this line integral to get the result minus 2 root 2 pi a square, where C is the curve given by this sphere and this plane, which means C is what? It is the intersection of this sphere and this plane, right? So the curve C is the intersection of the sphere and the plane. So the sphere is having the center at a0, right? That is, if this is your x-axis, y-z, and the center is about here. It's a 3D dimension, so let's say the center is here. And the plane given to us is x plus y equal to 2a. So for the plane, if I take x to be equal to 0, I get the point y to be equal to 2a. So that means this one. And if y is equal to 0, I get x equal to 2a. So the point is this. This is your distance a, and this is a. And if I take y to be equal to a, I get the value of x to be equal to a. So that means at the center. So which means the plane passes through the center of the sphere, right? This is your sphere. This is your plane. And the intersection of the sphere and the plane is forming a circle. Since the center of this circle is also the center of the sphere, that is a0. So the center of the circle and the center of the sphere is same. So that means we are getting the great circle. So therefore I am getting C to be the great circle. And what is the radius of this great circle? It is same as that of the radius of the sphere. Yes? So the radius of great circle is equal to the radius of the sphere. That is equal to square root of, okay, what is the center? It is, the center of the sphere is a0. So the radius, it becomes a square plus 0 squared under the root minus, so that is equal to square root of 2a square, which is equal to square root of 2 into a. And now let's evaluate this given line integral. So this is equal to the integration over the curve C. I can write this as the dot product of yi vector plus zj vector plus xk vector, taking its dot product with dxi vector plus dyj vector plus dzk vector. For if I take r vector to be xi vector plus yj vector plus zk vector, from here I get this to be as dr vector. So writing this further as the line integral of yi vector plus zj vector plus xk vector, I am writing this to be as dr vector. Fine? Okay. Now if I suppose this to be f vector and this is dot product with dr vector, now I can apply the Stokes theorem over here. So this integral, the Stokes theorem is what? This line integral is equal to the surface integral of curl of this f vector. Yes? And its dot product with n vector ds using Stokes theorem. Right? Okay. Rest we need to find the curl of this vector and also what is n vector. Yes? Please mark this as 1. On the left hand side I am having the line integral of f vector dot dr vector, where we have taken this to be our f vector. So let's evaluate first the curl of f vector, that is equal to the curl of yi vector zj vector plus xk vector. Just write here I vector, j vector and k vector. Curl by curl x, curl by curl y, curl by curl z. Writing here the first component of f vector, that is y. Then the second component, that is z. And then the third component, that is x. Solving this further, we get I vector into, okay, partial derivative of x with respect to y is 0 minus partial derivative of z with respect to z is 1 minus j vector. Partial derivative of x with respect to x is 1 minus partial derivative of y with respect to z is 0 plus k vector. Partial derivative of z with respect to x is 0 minus partial derivative of y with respect to y is 1. So we get minus I vector minus j vector minus k vector. And still we need to find what is n vector. Now the plane given to us is x plus y is equal to 2a. Right? What are the direction ratios of the normal to this plane? Yes, it is. What is the coefficient of x? It is 1. The coefficient of y is 1. The coefficient of z is 0. So these are the direction ratios of normal to this plane. Right? Since the direction ratios of the normal to the plane x plus y equal to 2a is 1, 1, 0. So therefore the direction ratios of the normal at any point of the circle, the given circle, are 1, 1, 0. Very fine? Okay. Please note that for a plane ax plus by equal to d, the unit normal vector is equal to the vector ab divided by square root of a square plus b square. Or we can also write this as in a vector format, ai vector plus bj vector divided by, this is nothing but mod of ai vector plus bj vector. So for this plane, we are having n vector to be equal to, yes, coefficient of x is 1. So this is I vector plus coefficient of y is also 1. So this is j vector divided by mod of I vector plus j vector. Very fine? Okay. So this is I vector plus j vector and mod of this is square root of 1 square plus 1 square, that is equal to I vector plus j vector divided by square root 2. Right? Okay. So let's put this value of n vector back to the equation 1 here, and also we need to put the value of curl of f over here. Let's first find the dot product of these two. So I'm writing this as minus of I vector plus j vector plus k vector, taking its dot product with the n vector. This is n vector. So this is I vector plus j vector. I'm writing 1 by root 2 outside of these two brackets. So this is minus 1 by root 2. I dot I is 1 and I dot j, I dot k, all these are 0. So plus j dot j is also 1. That's it. So this is minus 2 divided by square root of 2. Rationalizing this, we get minus 2 square root 2 divided by square root 2 into square root 2, that is equal to. So this is minus square root 2. So now put this value in 1, we get from 1 on the left hand side we are having the line integral of f vector dot dr vector. So this is equal to the surface integral of curl of f vector dot product with n vector ds. That is equal to the surface integral. The value for this is minus square root 2 ds. That is equal to minus of square root 2 the surface integral of what is the area of the circle C. This is your area of the circle C, and that is equal to pi r square. What is the radius? We have found this radius to be square root 2a. So square root 2a square. That is 2 pi a square. So this is equal to minus of square root 2 into the area of the circle, that is 2 pi a square. So when multiplying this, we get the value of the surface integral to be. So this is minus 2 root 2 pi a square, which is the required right hand side we needed to prove, and we have proved this. Okay, thank you. Stay blessed.